I did cook out yesterday. That I did do. Somebody lost their phone.
Do the grill.
So.
No, my mom does that to me all the time. If I don't get to her, she says my wire cut off. I'm like, bro, I'm trying to take a nap.
Wonderful.
She can set your phone off.
Well, it's a morning conference. That's how we start out. So there, then it gets less exciting.
I'm talking on Friday.
Nope. That's as good as I get.
I'm talking on Friday.
Take what you can get. Take it or leave it. Either way, that's it.
No, I don't. She's always watching it. The only reason my mom has it is because with me driving and still being new at driving, she wants to know if I'm okay. And it with each location. I turn it off if I go to a friend's store. No, my parents found out I took off my location. They have a whole. It would be horrible.
I do, but I have no idea what that sounds like. I don't really think I want to know either.
I would be grounded to the house until I turn 18. How long do you have?
I guess it would be a year and a half.
Yeah.
I told you to have one. That means you should try to. Morning. You're not trying. Not good. Not good. Not good. Good morning, ladies and gentlemen. Welcome to Monday. Wow, a little feigned enthusiasm. Love that. Love that. Love that, ladies and gentlemen.
What do you want from us?
Monday, fresh way to start the week. Wait, where do you work? Where? I'm sorry. Oh, I love their buffet though. Cleaning up afterwards? That's okay. It could be worse. My parents ran a restaurant and they serve family style. You know what that means? All you can eat, but you got to bring it to the table. So, like every group that ever came in, there were like 1,000 dishes from them because it wasn't just the dishes they ate off of; it was everything you served off of. That was not fun. So, what's that? Oh.
How dare you, Quick? How dare you? Like that side, not that side.
All right.
Oh, that would suck.
Jeez, Louise, how can we not have our computer charged on a Monday morning?
I normally always have my computer charged, but 2 minutes right now.
Yeah, but you can't say that anymore. So, good morning, Christian.
I was like, I don't want Mr. Brandon to say that I call myself. So I charged it.
Good job. Good job. I mean, if I were you, I would put your Chromebook right by your phone or whatever you charge and put the two charging cords together and remember to charge them both each night.
Right. I would look right at it and still forget it.
Well, then there's no helping you, Jocelyn. Sorry. At that point, there's no helping you.
If I remember my friend, I text my friend and say, hey, remind me to grab this in the morning or I won't forget.
Why don't you just send yourself a text to remind you to bring something?
I'd rather have my friend does it.
So you'd rather bother your friend than just be responsible?
She reminds me.
What? You could set reminders and things in your phone. Come on.
Oh, yeah, that's extra. I don't know how to do that.
I don't know how to spell reminder on my phone. I have to ask my mom to help me.
Which is weird because normally you guys know more than.
Yeah.
Just go on your calendar.
There's a lot of things I don't know how to do with my phone that I'll be asking my mom.
Okay. So that should be our question of the day. What do you not know how to do on your phone that old people do?
I know everything.
Other than make a call. I mean,
MySpace.
Thank God I have my.
Whoa! Go
Wait,
to
what?
MySpace. That's like the old thing.
What's wrong with your space?
I said MySpace? Jesus, I haven't heard of that in forever.
Yes.
I don't even know what MySpace is.
Like an early version of Facebook.
Okay, what's Facebook? No, that one I know. My wife's on Facebook. But the amazing part is she'll show me things and think that I actually follow things on something that I don't have. So she'll be like, look at this. Who is that? Well, that's so. Oh, why do I know about them? Well, you don't, but it's just a cool picture. No, it hasn't.
I had a MySpace account in like '98.
Ooh.
That's
Kevin,
old.
my gosh, why are
I
you
didn't
so
just say
old?
that you're old.
Why are you so old?
Thanks, Kevin.
Thanks, Kevin. Thanks for bringing back good memories. All right, ladies and gentlemen, get logged into your computer. I'll give you a code for Pear Deck today. Today we got a bunch of wrapping up and some reviewing to do because you've got a test on Wednesday, ladies and gentlemen.
Oh my God.
Misty quizzes. Loudly bothered. Quick X-ray.
Okay. I don't know why they don't use numbers in a Pear Deck so that you can, have numbers in there. I don't know. It's their thing, so I'm not going to argue with them. So hopefully you got outside yesterday, ladies and gentlemen, and enjoyed a beautiful Sunday day. No? Stuck inside working or what?
Yep.
Really? That sucks.
Really?
Man, that's
That's what I
terrible.
said.
I feel bad for you. I was outside. It was great.
I was
It was
outside only
great.
one day out of the two.
I was outside
Right.
from 6 to 8.
That was a big thing.
2 hours of outside I got. That's it.
2 hours of outside. That's better than none.
True.
I got out mainly most of the afternoon.
I was just outside.
Well,
I couldn't do that.
You could have come over. I have plenty of time.
I was working.
Yeah.
You get paid.
all right, ladies and gentlemen. So here we go. Today's Pear Deck is a little bit different.
Mr. Brad, my computer's not loading. Wait, don't start without me. I've been waiting for it to load.
Okay, well, I can't hold on forever.
I quit.
Try shutting it down and try turning it back on. That's what they always say. All the tech guys say, do that first. There's a button on the side.
Try the
You
volume.
turn your computer off.
Wow, okay.
No, I usually let it die.
Well, we're waiting for Jaslyn to get her computer started again. Today, we're going to again talk about which gas laws you're using, how to predict things with them, things like that, because that's what you're going to be asked to do on the quiz on Wednesday. So that is the reminder. The quiz is on Wednesday, ladies and gentlemen. Today, the gas law lab is due that we worked on Friday. That was the one where we went to the 4 different stations. We moved around to them. We will go over that tomorrow. That will be a good review before we do our test on Wednesday. So we'll go through that tomorrow, but I need those from you today. A few of you have turned them in. We'll give you some time to work on that today as well. Okay? So hopefully now you're logged in. I want a one-word answer. One word. You cannot change this about matter to make its kinetic energy increase. One word, that's the answer. What can you not change about matter to make its kinetic energy increase? Cannot change. P, okay. One word. One word is 2 words if you type it that way, ladies and gentlemen. So you can't give me an answer of one word. You cannot change this about matter to make its kinetic energy increase, ladies and gentlemen. The one word is mass. You cannot change its mass. Okay? Mass is determined by what that substance is. Okay? So the particles in this desk cannot get any heavier. You cannot make their energy increase by making them heavier. Okay? So mass is one thing you cannot change. In the Kelvin scale, temperatures are always one word. One word. What are temperatures always in the Kelvin scale? All right, let's see which one word you picked, ladies and gentlemen. Okay, some interesting choices there. Positive constant Celsius. I don't know how they're Celsius. Constant, K, positive, positive, positive. All right, ladies and gentlemen, the answer we were looking for was not showing up. Positive, ladies and gentlemen. Temperatures are always positive in the Kelvin scale. Okay? The Kelvin scale, they're always positive. One word answer. Pressure on the walls of a container is caused by particles doing what to the walls of the inside of the container? So pressure on the walls of a container is caused by particles doing what to the inside of the container? Remember, only a one-word answer, please. One-word answer. By the way, for this one, there can be more than one word, but I still only want one word. More than one way of saying it, I should say. Okay, do you people not understand what one word means? One word. One. Bouncing off the walls, not one word. Hitting against, not one word. Now, hitting is one word. That was good. That was good. Deleted response is two words. Pushing, bouncing, shape, force, exerting, bouncing. Hitting, bouncing, bombardment. Any of those would have been acceptable. I don't know how exertion would have really kind of fit. Because they're not really exerting the walls. They're just hitting against it. Okay? And that causes pressure. So the particles hitting against the walls causes pressure, ladies and gentlemen.
When my word still count?
What was your word?
The force.
No. It's got to be hitting. It's got to be bouncing. It's got to be... Boyle's law is what kind of relationship? One word answer, ladies and gentlemen. This one should get a little easier for you. Oh my goodness. I'm afraid to go down because we're doing so well at the start. Somebody's changing their constant to inverse as we speak right now. Who's typing? Inverse was the word that we were looking for, ladies and gentlemen. Inverse was the word that we were looking for. Now, we talked about there being constants in these relationships between the variables eventually. That is true, but inverse was the word we were looking for there. If the particles of matter move faster, it changes the matter's what? One word answer. One word. If the particles move faster, it changes the matter's what? One word. Again, multiple correct answers for this one. But make sure it's only one word, ladies and gentlemen.
Yeah.
Must be a hard question because we're losing a lot of people. Last one we had 9, 11, 10 people. Actually, this is one that I hadn't thought about. In this unit, that is correct. It could change the pressure if it were a gas. So, the word I was looking for, ladies and gentlemen, was temperature. You could have also said energy. Okay, it does change its energy, changes its temperature, and if you're talking about a gas, it would change its pressure as well. So good answers, ladies and gentlemen. Good answers. All right. One word answer. At absolute zero, particles will... One word.
This is harder. This one's harder, I think.
Well, you got to think about what particles do at absolute zero.
There's only,
Come on in.
this word will take 2 words.
Well, then you got to put it on to only one. Stop. Stop. Freeze. I guess I would need more context from that. Here's what I mean. If you're talking about freeze as far as something going from a liquid to a solid, no. If you're talking about, the police yelling at somebody, freeze, meaning stop, okay. Okay. So again, a couple different options there. Finally, one word answer. Volume describes a gas's volume describes a gas's
There's multiple answers you could get from that.
Well, put them down there and I'll see what they are. We'll see if they work. I don't know that there's multiple answers you could get, at least not that I'm thinking of.
I'm thinking of 2.
But again, sometimes you guys think of things that I don't. So
I'm thinking of 2.
put a comma in between them and type them both in. As long as they're 2 single words.
Oh, I can do that?
Sure.
Okay.
Amount, density, pressure, amount, mass, particles, intake, amount. Wow. No, volume describes a gas's space. Space, not the amount.
That's really good answers, though.
Not the, well, yeah, but not right. If you've got another way of coming up with space, that's fine, but it describes the amount of space something takes up. So it describes in gas's space. Okay? Amount is different. Amount is the mole. Okay? Amount is the mole. Volume is the space. Questions, ladies and gentlemen? All right. Okay. So here's what we got, ladies and gentlemen, for today. Let me end that. Get rid of that. There you go. All right. We've got 3 things I'm going to give you time to do. 1, some of you need a little more time to finish up your labs from the other day. Okay? Number 2, there was a worksheet that was assigned that we were going to do that was due on Friday. I think I got 4 from you guys, so you can have some time to work on that today. But number 3, the thing that we're going to start with, ladies and gentlemen, is you need to come up to the front. you need to grab a yellow, a green, and an orange highlighter and one of the worksheets that's up here. Please come on up and grab that. Okay? So there are 3 different highlighters you need, orange, green, and yellow. Well, if not, I have them up here for you if you want to use mine. Come on, Zoe. I picked the 3 most popular colors for highlighters.
I know. Also have blue, pink.
I got purple. You got purple?
No.
I got purple.
I got blue, pink.
I got blue and pink. Yep.
I got pink.
Right there.
I got all these. Those are all my highlighters. I have orange, pink, blue, green,
Oh, yeah.
yellow.
All right, ladies and gentlemen. So, here's what's going to happen. I'm going to show you what you're going to do on this, okay? And then we're going to give you some time. We're going to give you some time to finish your lab. That would be your number 1 priority. If you're not done with your lab, finish your lab. Number 2, finish up this worksheet and the other worksheet. And then by the end of the hour, ladies and gentlemen, probably with about 15 minutes left, we will go over this worksheet and the other worksheet that was due last week, Friday. So you've got those answers so that you can have those before your test on Wednesday. But again, we'll give you some time to work on all 3 of those things. But again, the most important thing that you can do is get your lab finished because your lab actually counts towards your grade. These will help you on your test, but they do not count for your grade. So let's show you what you're going to be doing today, ladies and gentlemen, and we're going to go old school here with highlighters, okay? Now, with your highlighters, ladies and gentlemen, we are using 3 different colors because there are 3 different variables, okay? So we are going to pick 1 for each variable. So what color, no. There we go. So what color do we want pressure to always be? Green, yellow, or pink? Or purple, or orange, sorry. Which one? Green. So for pressures, we're going to do those in green. So right now, I'll start by coloring the variable of pressure on your worksheets in green. Okay? That's what that is going to mean for us, ladies and gentlemen. All right. Volume, what color do you want it to be? Yellow or orange? Yellow or orange for volume? What? Yellow for volume? So, ladies and gentlemen, that means you have selected orange for temperature. Bless you. All right. Questions? Okay. So now what you are going to do, ladies and gentlemen, this is the first thing that we are going to do. You're going to read through the problems, the 5 problems, and with your highlighters, every number that is there, you are going to highlight it in the appropriate color. So what I mean is when you read through the problem, if it gives you a pressure, you're going to highlight that in green. If it gives you a volume, you're going to highlight that in yellow. And if it gives you a temperature, you're going to highlight that in orange. So a gas at 30 degrees Celsius. 30 degrees Celsius is a temperature, ladies and gentlemen. I'm going to highlight that in orange. Has a volume of 0.995 liters. I will highlight 0.995 liters in yellow. And a pressure of 736 mmHg. What pressure is needed for the same gas to occupy 1.25 liters? Yellow again because that is a volume. Why? Because of liters at 50 degrees Celsius. Okay? So, this is what I want you to do for the other 4 problems real quick, ladies and gentlemen. So, that's all we're going to do for just right now. We'll get into figuring more of this out in a minute. But for right now, ladies and gentlemen, go through problems 2, 3, 4, and 5 and do that same thing. If you come across a temperature, highlight it in orange. If you come across a volume, highlight it in yellow. And if you come across a pressure, highlight it in green. So we'll give you a few minutes to get that done, ladies and gentlemen. Okay, we've heard the clicking of the opening and closing of the cap stop, so I think everybody's pretty much ready to go. Okay, so let's make sure we got these correct, ladies and gentlemen, then I'll go back and show you what to do with the first one, and then we'll turn you loose with some time to work on some things, either alone or with a partner. All right, in number 2. All right, in number 2, what did you highlight in green? Just in green, what did you highlight in green, Mariana? Yep. Nothing. Good. Actually, if anything, you would have highlighted this down here. The pressure remains constant, which means it doesn't. I'm frozen, aren't I? Thank you. Good call. Sorry. All right. Sorry about that, ladies and gentlemen. So again, there were no pressures in green. So good. There was nothing to highlight there. All right. What did you highlight in yellow here, Christian? What did you highlight in yellow in number 2? Okay. All right. Alex, what did you highlight in yellow? 125 milliliter? Was that it? Good. That was all of them. All right. So then we need temperatures. What did you highlight for temperatures, Zoe?
So negative 20 Celsius
Okay. Anything else?
and the 0.0 Celsius.
Good. All right. Good. So we got everything highlighted there. All right. Let's go to number 3. And since I have the orange highlighter out, the temperatures, which ones did you highlight, Jimena, in number 3? What were your temperatures?
45.0.
Okay. And?
95.0.
Good. Sorry, ladies and gentlemen, my degrees sign got messed up when I made them a little bit bigger. Sorry about that. Let's go to yellow. So we're looking for volumes. What do you have for volumes here, Alexa?
8.50 liters.
Okay, was there another volume? Okay, good. By the way, when you don't find a second one, what does that normally mean? That's the one you're probably finding for. Good. All right. So then we've got to find some pressures here. What did we find for pressures? Brianna, what did you find for pressures? Okay. Very good. Excellent. Wonderful. All right. That's done with number 3 then, ladies and gentlemen. Okay. We're good. Let's move on to number 4. All right. So number 4. Again, I got my green out. So let's start with pressures. What were our pressures here, Lucy?
98.5 and 103.5.
Okay, excellent. All right, let's go to volumes next just because it's handy. Yellow for volumes. What'd you have, Jaslyn? I'm sorry, Jaslyn, I couldn't hear you. 325 milliliters. All right, good. Okay. All right. Was there another one, by the way? No. Okay. Nope, not another one. Good. Hello, sir. Grab a worksheet and a green, yellow, and orange highlighter on your way through. Okay. All right. So now I need temperatures. Victoria, what do you find for temperatures?
6.5 or 6.5 or no 65.0 Celsius.
Okay. All right. Okay. So this one we're going to have to look at a little bit closer. Why?
We have 2 missing.
We have 2 missing. We're missing a second temperature, and a second volume. So let's read this one. If 325 milliliters of gas exerts a pressure of 98.5 kPa at 65 degrees Celsius, what will the temperature be? Okay. So that means we're going to be solving for a temperature when the pressure is 100.3 kPa and the volume does not change. So we should highlight that part about the volume not changing because, again, like the problem earlier with Mariana, we didn't get any pressures in it. Why? Because it said the pressure wasn't changing. Here they did give us a volume, but they're telling us it doesn't change. Okay? So let's go to number 5, ladies and gentlemen. What are our volumes in number 5? What are the volumes in number 5, Helen?
5.25 liters.
Okay, and any others? Thank you, 1.20 liters. All right, let's go to temperature. Temperature, what do we got for temperatures here? Kevin, go, sorry. 12.0 Celsius and 285 Kelvin. Excellent, good. So what do I got for a pressure here? What do I got for pressure here, Ethan? Yep.
You have 4.52 psi.
All right. Okay. All right. Now, we are going to have one little problem with number 5. What I'm going to ask you to do in a minute is to compare and see what happens to pressures and volumes and temperatures in the problem. What is the problem in number 5 that we have? Go ahead, Kiana.
The Celsius and Kelvin.
it's going to be very difficult to tell if temperature is going up or down when we have them in two different units. Okay? So we have a choice here. We can either take our temperature in Kelvin and convert it back into Celsius, or take our temperature in Celsius and convert it to Kelvin. Which one do you want to do? 2 Kelvin?
2 Kelvin.
Okay. So let's take this 12 degrees, 12.0, and what do we add to it? 273. That will give us our temperature in Kelvin. What do we get? So what is that telling us, ladies and gentlemen? Oh, what? Temperature did not change. Temperature actually did not change here. 285 to 285. Temperature is not changing here. We'll have to keep that in mind. Okay? All right, let's go back to problem number 1, and we'll show you how you're going to finish these out, and then I will give you your time to work on these and your other things. Okay, so in this problem, which one are we solving for? Pressure. The second line of it says what pressure is needed. So therefore, we're solving for pressure. So with your green highlighter, we're going to highlight the green question mark by pressure, because that's the one of the 3 that we're solving for. If you were solving for volume, we would have highlighted the yellow question mark. If we were solving for temperature, we would have highlighted the orange one. Okay? Now, because of that, we should be able to tell how volume and temperature are changing, or if they are not. Okay? So, what is volume doing in this problem, ladies and gentlemen? And by the way, I got my yellow highlighter because we're talking about volume. What is volume doing in this problem?
Going up.
Volume's going up. So I'm going to highlight that here. Volume is going up. Okay? Now, it doesn't, I'm sorry, ladies and gentlemen, I printed these in black and white, so it didn't work out for me. But where it has prediction in the last column, one of these is going to be for volume and one of these is going to be for temperature. It doesn't matter which is which. So if the volume goes up, what does that cause the pressure to do, ladies and gentlemen, according to Boyle's law? Go down. So that's what I'm going to do there. I'm going to take one of those 2 sets of arrows and I'm going to highlight one going down. Okay? Now, I'm going to take my orange highlighter and we're going to look at what did temperature do? Did temperature go up or down? Did it stay the same, or can't you tell? It went up. Went from 30 degrees to 50 degrees. It's going up. Okay? What would that cause pressure to then do if temperature goes up? So I'm going to highlight the one on the bottom for it increasing. Okay. So right now, ladies and gentlemen, okay, what is going to happen to pressure in this problem? Does it go up? Does it go down? Or can't you tell? How do you know? No. Well, which way are the 2 arrows going, Victoria?
Oh, it would go up because there's more going up than there's going down.
There's just as many going. Well, here's the thing. You can't count up and down arrows. What I mean by that is you're right. Up, up, up. 3 of them going up. But this one causes this change. And this one causes this change. That's why we're using the colors. So when you look just at pressure, the 2 variables that are changing it, volume and temperature, are sending it in what direction?
Opposite.
Opposites. What does that mean when they're going in opposites? What? No. No.
Tell.
What?
Can't tell.
You can't tell. What it means is if we get 2 arrows here that are going in opposite directions, we can't tell. So what will happen to pressure? We can't tell. The only way we could tell is if both arrows were doing what?
Going up.
Going in the same direction. Let's say the same direction, because you're right. It could be going up or it could be going down. If they're going in the same direction, that's what this has to do. When one is up and one is down, now, again. Now, if something doesn't change, can it have an effect on something else? Not if it doesn't change.
Oh, no.
So if we get to a problem and one of these doesn't change, you don't do anything with it. You leave it out. Now there will only be one arrow here. Okay? Because if something doesn't change, it doesn't have an effect on it. All right? So you don't do anything over here if something doesn't change. And by the way, why do I have two there? Because this is the one I was predicting for. This is the one I was solving for. So I want to see how volume affects it and temperature. So yellow and yellow, orange and orange, so that we see what effect they have. If these were going in the same direction, we could say it's going up or it's going down. But because they're going in opposite, we cannot tell. And that's fair enough. Now, which gas law did we use? Boyle's, Charles, Gay-Lussac's, Avogadro's, or combined? How many things changed? Technically, 3. Okay? So which gas law is it when you have 3 things changing?
Combined.
It's combined. If one of these was constant, any one, meaning we didn't do anything over in here because it didn't change, then it's going to be Boyle's, Charles, or Gay-Lussac's. But if you get 2 things affecting the one that is changing, it's got to be combined gas laws. Okay? Got to be combined gas laws. Questions? All right. So you have, yes, go ahead.
When you can't tell like what will happen, does that always mean there's going to be like combined gas law or no?
If you can't tell what's happening, it has to be combined gas law. Yes, great point. Because if volume doesn't change, and this one does, it's definitely going to cause this one to change. Definitely. Go up or go down. No questions. But when you have combined gas laws and you have 2 variables, they can be sending the third one in opposite directions, in which case we can't tell. In which case, the only way to know what would happen to this one is to actually do the math, and we're not going there. Okay? But yes, if one is going up and one is going down, we can't tell. We just leave it at that. We say we can't tell. If they're both pointing down, it's going to go down. If they're both pointing up, it's going to go up. Okay? And remember, don't count the up arrows. It's what happens in this set of boxes that tells us what is going to happen. This causes this. This causes this. These 2 are Boyle's law. These 2 are Gay-Lussac's law. But it's a combination of what happens in Boyle's and Gay-Lussac's that would tell what is going to go on with the pressure. Okay? Questions? So you've got 4 more to do here. And that's all you need to do. Fill this out here. One of 3 things. Goes up, goes down, you can't tell. And then which gas law you think caused it. Okay? By the way, if it's can't tell, has to be combined gas laws. If it's up or down, it could be any of them. Okay? So, you have got, ladies and gentlemen, about 30 minutes left to class. Okay? As long as you're working and as long as you're busy, we will keep giving you time. If we do not get through this today, we will review it tomorrow before your test for sure. But again, number 1, get your gas law lab done. The one from last week, Friday, the 4 stations. Get it done, get it turned in, get it finished. If you have questions, you got a half an hour of me here to help you. Number 2, get this one done. And number 3, if you didn't finish the one from last week, Friday, get that one done. Those are all good practice, and we will go over them before your quiz or your test on Wednesday. So there you go, ladies and gentlemen. Go to work, okay? Make sure you get things done. If you have questions, call me over. Yes, sir, Christopher.
What's the test about? Is it about like just...
Well, that's what I'm saying. A lot of this is what is on the test.
Okay.
These gas laws. If I change this, what happens to this? Making that prediction. Not doing the math, but being able to tell me that one is going to go up, that one's going to go down, or you can't tell. Okay? So this is a great review before your test because that's a lot of what is on it. Okay? All right, ladies and gentlemen, go to work. If you have questions, you can raise your hand, call me over, and I will be happy to answer them for you. You may. Go ahead.